Welcome back. I'm continuing on with this virtual fuzz pedal simulation, MultiSim 1 Lab. If you haven't done so already, we're going to move on. It's a good time to save. I'm going to go back to just schematic view here, stop it if I got interactive mode going on. I'm going to save my circuit. And going back to the instructions here, we're going to add a diode. Because right now what we have created is some transistor clipping, some asymmetric transistor clipping. And it sounds good on the guitar, but we want to add a little bit more distortion because more is always better. And we're going to do that with some diodes. So let's add a diode here. It doesn't, and D is for diode. Does that work? Doesn't that work? It doesn't appear to work. We'll go to passive, and I guess it's, where are the diodes? That's diode right there. Lots of diodes in the real world, but only one simulated normal diode here, and that's cool. And I'm going to rotate it, and we're going to connect it between ground and the positive audio rail. So hit my J, and we'll add a little bit. Let's extend some things here. Let's extend this outward a little bit. J. And we'll take this guy, and I'm also going to extend it outward a little bit to say there. J. There we go. And we're going to put our diode in between these two. So there we go. And this guy. And I think in my instructions at this point I have you move the voltage probe to the output. So let's do that. We'll grab that probe and move it over here. By the way, if you're getting warning signs like this out of date, that's totally expected. That's because we have changed the circuit and the values here are now wrong and you have to run the simulation again. So don't be weird. Don't be freaked out about that at all. That's totally normal. Now we could measure this right now and see what it's like, but we're actually going to put in two diodes in opposite directions so they can clip both sides of the waveform. So I'm going to reverse it the other way. I should have done that. Keep going, Eric. Keep going. There we go. And I'll move this one slightly over there. And let's add that connection. And we'll add this connection. And now we've got a diode going both ways. And this is going to create, as I said a moment ago, well, maybe I did or maybe didn't, this is going to create symmetric clipping. What a diode does is it passes current through it when it goes above a certain voltage. And so you imagine you have this audio signal coming through here, and it's varying in amplitude all the time. In this case, it's a sine wave. And some points it's high in voltage, and some points it's low in voltage. Well, when it's high enough in voltage to go over the forward voltage of the diode, it's going to pass that to ground and go away. It's going to be gone. And that's going to do, and since the diodes are going in opposite directions, one of these is going to pass the tops, the peaks, the positive peaks to ground, and the other one is going to pass the negative peaks to ground. And you're going to chop off both sides of the waveform and get symmetrical distortion and get more harmonics, which is cool. So let's see what that looks like. The best way to do that is to get the oscilloscope out again. So we'll split our view here, and I'm going to set this up so I can see my whole circuit over here. I kind of like seeing what's going on. And let's press play. Boom. And we get a very different waveform than we did a moment ago. Now, the first thing you'll notice, it's a lot smaller. And a moment ago, it was way up here at 8 volts. Part of what's going on is that we're now seeing the effects of this 220 nanofarad coupling cap, which is getting rid of the DC offset and lowering the output. So the output now hovers in and around 0 volts. So that's what's going on here. So what we want to do is maybe make this oscilloscope center itself. A couple ways you can do that. I've gone over here. If you click, depending on which screen you're in, you will get different settings over here. And I'm looking at the oscilloscope settings. I'm pretty sure if you hit this voltage button, it will center it. There, that did it. You can also change the extents down here. It was to 8 volts maximum. Now it's only 0.8 volts. And so what we see here, and this is pretty cool, I'll hide this, is that the input voltage is sinusoidal and small, and the output voltage is still asymmetric. because the transistor clipping is asymmetric. But it does have far more clipping on both sides than it did before we added the diode. And the diodes, they will clip both sides. So you can really see that it's been squared off. Now, I would recommend you open up your screenshot from a moment ago and compare the two results. And that's what I've done here in the instructions. This is the transistor clipping only. And you can definitely see the DC offset. You can see how everything is positive voltage, but it's less squared off than here. Now we have a much smaller output voltage. It is hovering around 0 with our diodes, and it's more squared off. So it's pretty cool. You can see the effects of this, which we heard this in class hopefully as well. You hopefully did this lab in class where you actually made the circuit and got to hear a guitar through it. Now if you want to play with some things, this is kind of fun to do a little bit of tweaking. One thing you can do is get rid of one of the diodes and see its effects. You have to stop the simulator to do that and go, what's it look like with one diode? And you can always undo really easily. That's what this little back arrow does. I'll put that back. Let's delete this diode and see what its effects are. And so you start seeing them very different circuits. And I had fun doing this at home, and I did this with a real oscilloscope, and I was changing the diodes and direction and all that. One thing that's real cool is, and you can do this in real time, is you can bring up the oscillator and change its voltage. And you can see how non-linear this whole thing is. You can really see how the input level changes linearly, but the clipping is non-linear and starts to change dramatically depending on how you saturate it. So that's pretty fun as well. I recommend you trying to do that. Anyway, when you're all done here, get ready. You are basically done with the assignment. Please take and zoom out and take a screenshot of the oscilloscope and your entire circuit and make sure you have your name in it, something like this where the whole thing is selected. And that's what you're going to submit. You're also going to take and submit your name of your file in the Canvas, so I know where to find it if I need to find it on the internet. And you're going to take these 3 screenshots you've done, the scope, circuit, and the final screenshot will be named final. And you're going to zip them up into a cute little folder and submit that folder, zipped folder, on Canvas. And if you comply with everything required on the rubric here, you'll get full credit. All right? Thank you for having fun, following me along if you're watching this video. Have a great day. Bye-bye.